Hi folks. So today we're going to look at implementing a LayerZero composed call. So when we think of LayerZero, we kind of think of one contract on chain A interacting with a contract on chain B, but there's much more powerful patterns you can construct using LayerZero. So with a composed call, what we're going to do is we're going to have a contract on chain A that's going to communicate through LayerZero to a contract on chain B, and then it's also going to pass a message on to a subsequent contract on chain B. So it'll be A, B1, B2. And you'll see the kind of a high level diagram here on screen of what we're looking to build. What we have is we have two contracts on base Sepolia and two on Arbitrum Sepolia. They are the same contracts on both chains. We see the contract one there is an OAP called Vault. And the second one is an OFT called Token. What we're going to do is deploy it into both chains, wire them up. So we wire the OAPs up together, and then we wire the OFTs up together. And then what we're going to do is we're going to send our compose call. And what's really doing is we're depositing some ETH from our wallet into the vault on base. That's going to communicate through LayerZero to our vault on Arb Sepolia. And then what it's going to do is it's going to mint some tokens on Arb Sepolia using the token contract. So you can see how it's jumping through a couple of contracts rather than just A to B in that scenario there. Okay, so the first thing I'm going to do is get the project set up. So forge init. Just going to take out the template files from Foundry. Delete them. Now I'm just going to git add. So I'll have a clean git repo. First commit. Okay, here we go. Okay, so now what I'm going to do is I'm going to install our contracts. So here's the three of them now. And this is Open Zeppelin contracts version 4.9.4 that we're installing. Just be careful if you're installing 5, you might get some issues. And then LayerZero v2 is the last one we're installing. Again, this will all be in the repo. I'll be in the repo, and I'm also linking an article on base.org for a base layer 2 that I found that was really helpful for us getting the LayerZero project set up. Now I'm just going to grab these remappings to Foundry.toml. So we installed our contracts, and then we're doing our remappings. So with those contract installations, these remappings should work. And again, they're going to be in the repo down below this down below the video. Okay, let's git add. Okay, here we go. So first thing I'm going to do is create our token and vault files. So we got token, that's all. Okay. Now, rather than just writing everything out from scratch, because we're not, it's not really about kind of learning Solidity or implementing an application. It's more about learning LayerZero, how it works, and how we can wire everything up and get it all working. So I'm not going to write the Solidity from scratch. What I'm going to do is I'm going to copy it out of my my other repo and paste it in. So this is the token. There we go. And what I will do is I will just talk through these contracts. They're very short. They're very straightforward. It's really just about seeing how they interact when we're using LayerZero. So just give me a second. There we go. Okay, so they're there now. So firstly, I'm going to go to our vault. So this is our main contract. So you can see from our vault what we're doing is we're importing OAP and ownable. We have a few storage vars here. The token, which is going to be setting it. So is that on Arbitrum when we send our send compose, or compose call. We're going to have to say where it's going to, and it's going to be to the token that we're going to mint. We use a collateral. This is just to track how much ether we've passed into the contract and base, and tokens minted. What we're doing here is we're just having a mapping here, so is that we're So that I want to kind of show that when, even though we're interacting with the vault on base, and then then it's passing over and interacting with the one on the vault on Arbitrum, that we can update the state. So we're going to update the tokens minted on the Arbitrum vault, which will be kind of the LZ receive hop in the entire interaction, and then we're also going to mint them on the token contract. So what we're doing is we're interacting. We're going to update the user collateral on the base vault. We're going to update the tokens minted on the Arbitrum vault, and we're also going to update the amount of tokens that the person has on the token contract. So just to show every part of the flow that you can interact with the contract. It's not just the first and the last hops. Okay, so going down, and we have a couple of things here, just errors and events and our constructor. Again, for a constructor, we pass in the LayerZero endpoint and the owner, and we pass them into the OAuth. I'm just transferring ownership for this. This is to do with create2, and that it doesn't. It's just to do with what account actually creates the contract. So I'll talk about that later when we're doing our deployment scripts. And for our functions, are very straightforward. I think you can probably read these yourselves. Just apply some ETH into the contract and update the mapping. And then for withdraw, we just retrieve the mapping to see how much they're due out of the contract, and we pass it back out. We're not doing anything with it, so it just sits there idle in the contract. But I just wanted to have something that the user can interact with that would kind of allow or disallow them from calling LZ send. So once they have some ETH in the contract, then they're able to call the LZ send. So this is the kind of the business end of the contract, really, where the magic happens. And what we're having here is the user can call the external function LZ send, and what they do is they pass in the destination ID, which will be, in our case, is going to be Arbitrum. The Arbitrum LZ endpoint, the amount, which is the amount they want to mint of the token on the other end, the recipient, which is who's going to get it, which we're just going to pass the same wallet address through it all. We also have choice here. Now, I'm not using choice on the receiving end, but I do want to pass it over just so you can see that you can pass different variables over. So uint 256 an address and a uint 8, and you could potentially use the uint 8 on the other end to kind of to branch off your logic if you wanted. So I just wanted to kind of have that there to kind of illustrate that it's not just about sending one kind of a call that does one thing on the other end, but you can actually branch your logic off on the other end as well. So that's why that is there. And then our options, I'll discuss the options later on, because I'm going to use the options builder to build out our composed call options. And so what happens here then is, if the user has some collateral in it, ABI encode the amount of tokens that they're going to get in the receiving end, who's going to get them, and then the choice as well, which again I'm not really using. And then LZ send is called, and it passes in these values as well. This is all standard for LZ send. And then what happens then is, once our contracts are wired up, LZ send will call the LZ endpoint on the base of Apollyon network, and it'll pass the message through LayerZero over to our Arbitrum contract. Then on our Arbitrum contract, which is the same Solidity file or contract, the executor is going to call LZ receive, or the endpoint is going to call LZ receive, and it's going to pass in these params. And our payload, again, because we've encoded it up here with amount, recipient, and choice, it's going to decode it here, amount, recipient, and choice. Like I said, not using choice anywhere, but here what we have is, we're going to say on this contract, we're saying, okay, decode this, what's the amount and what's the recipient, update the tokens minted for the recipient to the amount. But then we're also taking the payload, and then we're passing it over, once again, calling send compose on the LayerZero endpoint, and we're saying, send the compose message to the token, which we've already set. It's going to be our token address in ARB. And then we have our global unique identifier. This is in an index, so I think if you were sending multiple compose calls, you'd have an index of 0 for this one, but then the next one will be 1, and so on. And again, our payload is passed on. So we're actually decoding our payload here. We're doing something on this contract, and then we're subsequently passing it on using send compose. So you can see how powerful that can be, that you're doing multiple hops throughout a different blockchain, and potentially back over to your original one or to a third blockchain. So it's very good. So that's our token, and I'll just skip over to our vault, or sorry, that's our vault. I just skip over to our token. So again, the token is very straightforward. It is just an OFT, and then we're going to wire them up so that you can actually transfer them between the different blockchains. And what we have here is, so OFT. So you'll probably have seen this before if you've been messing around with LayerZero. So it's an OFT because we're going to be minting the OFTs, but it also has this LayerZero composer, and this needs to be inherited in order to make in order so as that you can actually send compose calls to the contract. Okay, so again, constructor is all very straightforward. This is what we really want to see here. It's the LZ compose, okay? So we have it as LZ compose, and the executor calls this with the address of the OAP, the GUID, once again, the message that we're sending through, and another couple of parameters there. But really, what we're doing is we're just looking to decode the payload and get the message out. So once again, we decode our message. And it's these, it's the amount, the recipient, and the choice. And all we're doing is we're just calling our mint function with the recipient and the amount, and then it'll mint that amount of tokens to our recipient, and that's really it for the token perspective. So I'm just going to create our EMV file. And what I'll do is I'll paste in an example EMV. Again, the example EMV is going to be in the repo, so you can take that as a jumping off point for your own EMV. So back in here, and this is it here. Okay, so again, you're going to need these, and you're going to need your deployer public address, private key, and all that there. I already have some of this stuff, and I'm just going to paste it in, and we can use it. Okay, but from now, I'm just going to set this up, and then. So I just want to, after that, I just want to paste something into our Foundry TOML here. So this is just going to be for our deployment scripts. I just want to have our RPC endpoints in. We're only using base and Arbitrum, but I had that in from a previous project I was building. Okay, so we have Optimism in as well. So these are going to be used in our script files later on. Okay, and so I'm just going to close these down for now. And I will also add in. I'm going to do the make file as well while I'm here. Touch make file. Okay, we're going to open our make file. It's empty here. I'm going to paste in the make file that I already have done up, and we'll go over it all afterwards. Okay. Here we go. Okay. Okay, so what I think I'm going to do is I'm going to be pasting real values into this that I'm going to kind of try and keep it away from the video. What I'm going to do is I'm going to create another file, and I'll paste the stuff in there on the video while I'm at it as well. So I'm just going to do touch, and we call it example.env. Okay. Open example.env, and let's just copy this info. Copy. There we go. So what I'm going to do is I'm going to put my real values into the EMV file, and then when I'm pasting in the addresses, I'll pop them in here so that you can see exactly what I'm doing. Okay, so I have my EMV file set up. So what you'll need to do is just get yourself your RPC URLs here. So you can get them from, I have them from Alchemy, but you can get them from wherever you like. If it's QuickNode or Infura, and if you're using base and Arbitrum, these are going to be okay. And get your Block Explorer API keys, so your base scan or your Arbitrum scan or Arbiscan API keys. Leave these ones alone. Then what you do is paste whatever you're using as your deployer. Paste your public address in there, your private key in there. Obviously, don't use a wallet or real funds in it when you're doing this. This is just kind of demoing and stuff like that. And then for your deployer byte 32 address, it's going to be your public address. But what you're doing is you're going to take off the OX, and you're just going to paste the rest of it on here for that. Okay. So in fact, I can actually, for the public address, I can actually do that part myself now. So just give me 1 second. So my public address is this. The public address is this. So what you want to do is you just want to take from after the X, copy that, paste it on there, and that's going to be the byte 32 left padded representation of your address. It's just a private key I really want to keep secret from the EMV file. So if you do that, you should be good to go then. Once you have your Etherscan and your RPC URLs in there, you should be good to go. Okay, so we're just going to have a look at, I'm going to create one more file. I'm going to create in the test folder. So actually get rid of that. I'm going to create in the test folder. So clear, touch, test, we're going to call it options, builder.t.salt. And in here I'm going to paste in some code I've written. Okay, so this is not really a test, but I put it in here just to make it easier so that we can display it on screen. So when you are calling these commands in the make file or with LayerZero, you have to pass in options in order to send your messages through the LayerZero network. Okay, and they're in the form of these bytes arrays here. So what we have to do is get our composed options bytes or your received options bytes or whatever it is, and you'll see that in the example EMV. I have a couple here. Okay, so if you see this one here, that's composed options bytes. So you see how long it is because you're sending a receive call first, and then you're sending a composed after that. And if you're just sending an AB message, that's how it looks there. Okay, so that's 200,000 gas. These ones are configured slightly differently. And I'm just going to skip back over. So what I'm doing here is just to show you on screen to illustrate with the options how it works. So if we look here, this is a composed options, okay. And what we're doing is we're using the LayerZero's option builder, and we're importing it, and we're using it here to create our options. And then I'm just putting the options toString on the display, so on the console, so we can see it. So we do options builder new options, add executor LZ receive option, 700,000 gas, and then add executor LZ compose option, and then we're adding in another 700,000, and I think this is index as well, so the index is 0. We're only sending 1. So what I'm going to do is I'm just going to show you here really quickly. Clear this, and if we go like this, so I'm just going to run this as a test, just the easiest way to do it for me. Copy. Forge test, match test this, and we just go. We should console log what we have here. So as you can see there, we're adding our receive option, which is our A to B1, and then our compose option, which is B1 to B2, and then it combines them into the options, and then we pass them in our send command, so that LayerZero knows it's a compose call. Okay, and if you can see that there, that's what it is. So when we have 700,000, and if I go back to the example EMV, and I just minimize that, you'll see that this here, if I was to do composed options bytes equal, should be exactly the same. So there you go. So that's how that's constructed there. And just out of interest to show you how the other one is constructed. So it's 200,000. So if I do this, so I'm just going to go back over to our options builder, and I'll copy this and do this. There we go. Test build LZ. We do LZ receive options, and we're going to say receive here, receive. And we'll take out the LZ compose part of it. Should be okay. Let me see. So LZ receive, new options there. Yep. So I'm just going to let me do this. And what I'll do is I'll actually change this to 200,000 just so it's exact, just so it's exactly the same as it is in the EMV file. Let me do this again. Clear. Just going to go forge test, match test, and it should end in 30. B40, I think, is that correct? 30D40. So we copy that there. Go back over here. You can see that. AB message options bytes, and it should be the exact same. Yes, it is. So that's just how they are constructed. If you're looking at the options builder and trying to get a grip on how it works. So an AB only takes add executor LZ receive because you just want to receive it on one end, whereas a compose call is longer because you have to add on another the LZ compose option for that. Okay, so that's just that again. Once again, it's in the repo, so you can have a play around with that yourself. So next we're going to create our deployment scripts next. So if I'm just clear on that. So we're going to go touch script and deploy to arbitrum dot s.sol for script. Should be right. Okay. Let me see. Okay. And I've already done up the deployment script, so I'm going to paste it in. There we go. And I'll just do deploy to base while I'm at it. just copy the file. There we go. And while I'm at it, I will do our set pairs. Okay, so I'm just going to close these and just have a quick look at the deploy. Have a look at deploy the base. All right, 1 second. Okay, it'll pull that from our EMV file. So if you've that populated, the base LT endpoint will pull that from EMV file and deploy our public address. Once again, these are all come from our EMV file. And then we skip down here. So VM create select fork base. When you're deploying to a blockchain, rather than fork in a script file, when you do VMs create select fork, you're actually it's gonna look at foundry.toml and it's gonna look for what you've said there. So in our case, we said base there, and it's gonna pull in your base Apolia RPC URL. Okay, so that's what's happening there. Is we're actually saying no, it's not really fork. We're actually saying select base, and we're gonna broadcast it after that using the private key. So you see here our base OAP, creating a new vault. If you're redeploying this a couple of times because you're tricking around and you're trying to change things and you know you're trying to figure it out, change the salt every time, or else when you try to redeploy the base. So if you redeploy the base using Albatross, you might want to change it to Seagull or Eagle or something like that, or whatever. It can be XYZ. It doesn't really matter. Just make sure to change it there and also to change it here the next time. So that's your salt. This is to make sure that both on base and on Arbitrum, using create 2. So when you put in salt, when you put this in here, Foundry will automatically use create 2 to deploy our contract, which will be a deterministic address. So our contract will have the same address on base and on once it has the same bytecode, I should say, it'll have the same address on base as it will on Arbitrum, and same for the OFT. Okay, again, that's why we have the salt in here. So really they're straightforward. All we're doing is we're deploying it. So vault base app, we're deploying your vault. We're then logging it to the screen so that we can get the address. And then we're doing the same for the OFT. And then down here, all we're doing is, because we now have our OAP deployed, we're calling the set token function on our base OAP, and we're passing in the base OFT. So it's, again, this is that when we call over to from our base OAP over to our Arbitrum OAP, we wanted to know where our base OFT is. So that's what we're setting the token there. And so this will deploy our contract to base, and Arbitrum will be the exact same. So it's fairly straightforward. Just deploy the 2 contracts and then call set token. And when we're doing it, when we're running these functions using our makefile, what we'll do is we'll take the deployed addresses on base and we'll paste them in here, and we'll have the bytes 32 version. Okay. So what we'll do now is we will move over to our set pairs script. Okay, so if I scroll up here to the top, what you'll see is we have a couple of imports. We're obviously importing our vault, our token, and script. So it's the script. I have put a couple of interfaces in here. So the only functions we need are set pair and set token on the vault, and set pair on the token itself. So I'll just put them in there to make them handy rather than importing them from a subfile. And our set pairs. So here's what's happening now. So again, we have our deployer private key, we've our OAP address and our OFT address pulled from our EMV file. So as you can see, those ones there. So once we deploy them, then we populate them in here, and then we run set pairs afterwards. Now, something to remember if you're redeploying these, or when you're deploying these, these have to be hard coded in here. I can't find a way of pulling byte 32 from our EMV. I'm sure there's a way of doing it. I'm just not entirely sure whether or not pulling in that format on the yeah. So look, I'll figure that out for a subsequent video. But for the time being, just when you have your OAP bytes 32 here and your OFT bytes 32 here, just remember to go back into to your set pairs before you run set pairs and put them in there as well. Okay. So they're all the ones that I would have deployed. Again, these are fine. These are just the base Sapolia LZ endpoint ID and the ARB Sapolia LZ endpoint ID. And then here we have the kind of the logic of it. Okay, so setting base period, and what we're doing is we're selecting, we're broadcasting the base to the base chain here using our deployer private key. We're calling on our OAP. We're saying set peer, and we're setting it, and we're set so on this one here. So of course we're on base. So we're calling our OAP address. We're calling set peer on it, and we're saying it's the Arbitrum LZ endpoint address, and then here's the OAP on the other end, which will be the other vault, and then we're doing the same for the token, okay? And then again, set the token address in the vault contract. We're doing that there, okay? And then we're doing the exact same again for the Arbitrum one. So when these are run, what will happen is that we'll have deployed our two contracts, the base and Arbitrum. We'll have put our information in here, our contract addresses in here, and then when we run set peers, it should wire everything up for us. And then we're really ready to just send our transaction through LayerZero or send our compose call. Okay, so I think we're ready to hop on over and basically deploy our contracts and yeah, deploy our contracts now. So again, you'll have to put all your information in here that you're going to need. So your API keys and so on. But I already have them in EMV. So I'm just going to switch over to the make file. And scroll up to the top. Yeah. Okay. So the first thing we're going to do obviously is deploy our contracts. So I'm just going to clear this. And the first thing I'll do is actually change the this I'm just going to change it to XYZ because I probably have already deployed using the word albatross. XYZ. XYZ. Okay. Now, so I'll copy our boil here. So again, these are straightforward the deployment scripts. There's nothing kind of too crazy going on. I've already set my deployer as in Foundry, so I've put instructions in the repo if you haven't done this in Foundry, so it's that it prompts you for a password rather than so deploying the base. There we go. If I scroll back up here, let's see my my vault OAP address, which is this one. So I'm going to copy this, and on the example EMV, I'm going to show you. So our vault, which is our OAP, you do this. I'm going to copy it from after the X over. I'm going to paste this on here because this is our bytes 32 version. And then I'll go over here and I'm going to copy our OFT. Paste that there. And once again, after the X, after the OX, just copy from 6 onwards. There we go. And what I'm going to do now is I'm just going to copy these into our set pairs. So I believe the first one was the OAP. So copy that. To our set pairs. So OAP bytes 32. Again, it's hard coded in here. Copy this one over here into our. There we go. What I'm going to do is I'm going to cut this part of the video out, but I'm going to paste these into my own one now as well. Now we should be good to run our set pairs. So I will click back over here to the make file. Oh, actually, sorry, I have to deploy to Arbitrum first. I actually forgot. And they will have the same. The reason I forgot about that is that they will actually have the same address. So it looked like the EMV file was done, but it's not. So make deploy to contract to Arbitrum. While that's running, I'll just check the addresses up here. So, DC2, 69B, DC2, yes, correct, 69B, and then the second one is 60 and 302. Yeah, so you can see that the addresses are going to be the same on both networks, as we're using create2 rather than just create. Give that a second to deploy. There we go. We have our contracts now deployed to both chains, and the last thing to do is to to word them up. So we go down here. Set pairs, very straightforward. Just going to run the set pairs script, or script. So make okay. Now what we're going to do is we're just going to deposit some ETH on base. Straightforward function. That's completed. Now finally, we're getting down to our LayerZero functionality here. So first thing I'll do is actually I'll just do this, because this is going to be 0. So if I go make, there we go. So it's 0, yeah, because of course we've no tokens minted on our ARB OFT, okay. But what we're going to do now is we're going to send compose call. I'm just going to copy this quickly. What we're doing is cast send, so we're sending to our OAP on base, because we're using the base Apolia network, and we're calling the send function, okay? And as we have here, the uint the 32 is our destination ID, our LayerZero destination ID, which is going to be ARB. The uint is going to be the amount, the address is going to be the recipient, the choice is going to be unused, but we're just putting it as 1 here, and then the bytes is going to be our composed message option bytes, okay, which we have. So again, so if you see here, arbitrum Apolia LZ endpoint ID, switch over here, arbitrum Apolia LZ endpoint, where is it, ID? ID, yes, so it's going to be going to this, so that's going to be 40231. Skip back over, or sorry, back to where, our make file. And then I'm saying for the uint, so the amount that I want is going to be 123 the tokens with 18 zeros after. Then deploy our public address, which again is in here. So that's going to be your account there. We want to receive it to our wallet just to make it easy. You could do it to another wallet if you want. That's no problem. Just use a different wallet if you want to test it out. One I just have as to pass any value in. That's a uint date, and the compose message option bytes. Again, in here you'll see that it's this here, and that we're doing a compose call. So tell LayerZero doing a compose call on what to use. And go back over. So that's it. And again, I'm using the deployer account. You can set that up using the instructions in the repo. So I'm just going to go back here, and we are going to just do make send compose call. Yeah, the call should be quick enough to hit base, but then it's going to go through the LayerZero messaging network. Okay, so it's happened on base there. Okay. I'm going to clear this. You can see now, if I go back here and I do, I go back to this one, this should still be 0. Okay? And what I'm going to do is, I'm just going to switch over to the LayerZero scan testnet and show you the transaction going through. Okay, so it took a few minutes for our message to pass through LayerZero network there. Again, these are this is base Apolia and ARBs Apolia, so they're probably at the highest priority networks, test nets for executors to be picking up the transactions. But it did go through after about 5 minutes. So you can see there it's being delivered. And if I switch back over to VS Code, there we go. And I go here. So again, I call this one more time, and you see now it's 123. So we have 123 tokens minted on Arbitrum. So what we've done is we have collateralized our position on the base vault by sending in some ETH. Then that enables us to call the send function, which triggers a LayerZero send through to the LayerZero endpoint. That passes through the LayerZero message passing network over to the Arbitrum Sepolia network to our vault there. We update our mapping on the vault contract on Arb, and then that does a compose call out to our token contract and it mints the tokens to our account. And there you have it. So that's an A, B1, B2, otherwise known as the compose call. Sure, have a look at the repo, download it, and try it out for yourselves. Thanks very much.